This is AP Calculus 511, solving optimization problems. On the AP test, you're going to have a lot of applications for relative maximum minimums or local maximum minimum problems. They very rarely will use the term relative or local extrema. Instead, they're going to disguise these problems into real life situations. Some common terms that you might hear would be maximize, minimize, find the greatest or smallest value, find the cheapest or the fastest value. They'll use the words most and least, furthest and closest. We're going to do two examples of these type of problems. We're going to read the examples together and talk about them a little bit, and then I'm going to go to the whiteboard to finish them off. For example 1, it says Android has started selling a new type of smartphone at a price of $110 minus 0.05x, where x is the number of phones manufactured per day. The parts for each smartphone cost $50, and labor and overhead for running the plant costs $6,000 per day. How many smartphones should Android manufacture and sell per day to gain the greatest profit possible? So we're looking for the greatest profit. So there are a couple things that you need to realize here when you're talking about profit. Keep in mind that profit is the same thing as revenue, the total amount of money you bring in, minus the cost of production. If we're going to think about this problem in terms of a real life math problem and how to set it up, we're going to have to take profit, that'll be P, represents profit per day, and X, they already told us, represents the number of phones manufactured per day. So if we use profit is equal to revenue minus cost, what we need to do here is we need to think of a math expression for revenue and subtract from that a math expression for cost, using P and X as our two variables. P represents the profit, the total profit, and then revenue minus the cost. Now, where did this equation come from? Well, if you think about it, revenue is going to be the price per phone times the number of phones manufactured. That's the total revenue, assuming you're selling all of the phones produced. We're going to subtract from that the cost. Now, if you think about what cost entails, the cost of your parts times the number of phones that you've manufactured. Every phone has the same amount of cost associated with it. So if you multiply the number of phones times how much they cost to produce, and then add to that the $6,000 to run the plant, that gives you your entire cost of generating the phone. So if you think about that, this part of the equation is your revenue, this part of your equation is your cost. So if you think about how to interpret that equation and put the numbers into the equation, we were told in the reading that the price of a phone was $110 minus 0.05x. So that would represent our price per phone, and then the number of phones manufactured, they told us, or we defined as x. So that's times x, minus, this would represent your total cost. Your parts cost, they told us in the reading, was $50 times the number of phones, which was X, plus the amount to run the plant. It says here that running the plant costs $6,000 per day. So that's going to be an additional $6,000 added to the cost that it is to manufacture each phone. So this is total revenue minus total cost to give you your final profit. And then if we just multiply these together, we'll end up with 110x minus 0.05x squared, and then distribute the minus sign. That's minus 50x minus 6,000. And then we add our like terms here to give us 60x minus 0.05x squared minus 6,000. To maximize my profit, I do need to take the derivative of this equation. So I'm going to find P prime. When I do that, I have 60 minus 0.1x minus 0, and then once I have taken the derivative, I have to set the derivative equal to 0 to find my critical values. When I do that, I have 60 equals 0.1x, so x is equal to 600. That is the only critical value that I've generated, so that means that would be the value that will maximize my profit. And again, I could set up my intervals, and this is the last time I'm going to do this, but I could set up my intervals that way, and I could pick a value within this interval, pick a value within this interval, plug back into the derivative. If I plug 1 in here, I'll have 60 minus 0.1, which is a positive. If I plug 1,000 in, I would have 60 minus 100, which is a negative, showing me that that is, in fact, the direction for a maximum. So this is, in fact, my maximum because it's going to show up that way. The only time you really need to do this is if you end up with more than one critical value that could possibly be an answer. So we can assume that it's okay to say 600 is the interpretation of the answer of this problem. And so to interpret what I've gotten here, to answer the question that they're asking, I would say that the Android company will need to produce at least 600 phones to maximize the profit. When you're taking an AP test, they are going to want you to justify your answers and justify how you got the information, or interpret what the information that you're getting out of the equation, what it means. So that interpretation does become very important when we're talking about the AP test. A lot of your points are going to be gained by being able to explain what your answers mean. You would get points for doing all this work, but you don't want to lose these points for the interpretation. So make sure you're always following those directions. When it asks you to justify your answer, that you do put a sentence down that tells what the answer is telling you. For problem number 2, it says find the dimensions and area of the largest rectangle that can be inscribed in a semicircle with radius 2. So the first thing I'm going to do here is draw a picture. I'm drawing the picture purposefully so that the center is at the origin, so that it will make it easier for me to find the dimensions of the length and the width. So here I've got it drawn. The radius is 2. Your origin is right here. I only included the positive part of the semicircle, in other words, where we go right and up or left and up to get to our semicircle. Next, I need to inscribe the rectangle and where I think it might be to form the greatest rectangle possible. I could have drawn that anywhere. We're not going to know exactly what these ordered pairs are until we do the math. We know that the area of a rectangle is length times width. So if you think about that, the length of this rectangle would be this length right here. The width would be this right here. So if I label those with length and width, this would be my L and this would be my W. So if you think about what that means, if this is the origin, this right here would be half of the length, because if this is symmetrical about the y-axis, then this length has to be equal to this length. And if we think about this ordered pair right here, to get to that ordered pair, we would go right x and up y. What we're going to have to do here is find the coordinates of this ordered pair. So I'm going to take this diagram to the whiteboard and explain it further, and we will find the answers there. Okay, so I've rewritten the information that we generated in the last segment. They were asking us to maximize the area of the rectangle that can be inscribed into the semicircle. And if you think about that, we said that this ordered pair would be XY. And if we think about what that means in terms of area, we're trying to maximize the area. And so you might want to understand why I have this as being a 2x. I want to make sure that that's clear. If I inscribe a rectangle within a semicircle and we're trying to find the largest one, to get to this ordered pair, we're going right x and up y. Then if we use my equation here, can't I simplify that? This is my secondary equation. Can't I get y by itself here? So 4 minus x squared equals y squared. So the square root of 4 minus x squared will equal y. So isn't my y value here going to really be the square root of 4 minus y squared? So those ordered pairs would put me to the edge of my rectangle. This ordered pair would just be negative x square root of 4 minus y squared. But if we're trying to find area, we can't have a negative length. So what we have to understand is that if this is going to be the largest rectangle within that semicircle, then it has to be symmetrical about the y-axis there. So what that means is this length is the same as this length. So the length of my entire rectangle would be twice x. That's why we have a 2x here. So we've got area equals 2x times y. So now I know my area equals 2x times y, which is the square root of 4 minus x squared. This would be my primary equation because I'm maximizing my area. So my area formula is what I'm trying to maximize, making it the primary equation. Secondary equation was this one, which helped me find my y value. So the next thing I need to do is I need to take the derivative of this. Well, the derivative of this means I need to use the product rule. So if I do that, the derivative of the first thing is 2 times the original second plus the original first times the derivative of the second. I've got to use the chain rule here. So that would be a 1/2 times 4 minus x squared to the negative 1/2 times the derivative of the inside, a negative 2x. To clean that up a little bit, a prime equals 2 square root of 4 minus x squared. The 2 and the 1/2 cancel. I've got an x times a negative 2x. So that's going to be a negative 2x squared on top. And on the bottom, I will have a square root of 4 minus x squared. Now, keep in mind, a common mistake for this. People look at this and they say, oh, the square root of 4 is 2. The square root of x squared is x. That's 2 minus x. No, completely wrong. That's a difference of squares. That would be a 2 plus x and a 2 minus x. It is not a square number, so be careful there. I see that a lot, so don't make that mistake. Those algebra mistakes will kill you in calculus. You gotta make sure you're not doing those. I need to get a common denominator here. So I'm going to put a square root of 4 minus x squared on the bottom. If I put one on the bottom, I have to put one on top as well, 4 minus x squared. When I do that, that gets rid of the square root. So I've got a prime equals 2 times 4 minus x squared, which would be 8 minus 2x squared minus 2x squared all over my denominator. Okay, and so if I fix that, simplify that a little bit, I've got 8 minus 4x squared all over the square root of 4 minus x squared as my a prime. Okay, so there's my a prime. I'm going to erase this, make some room so that we can go from there. So once I have a prime, I need to set it equal to 0 to find my critical values. When that is equal to 0, I end up with 8 equals 4x squared. So if I simplify this, I'll have a 2 equals x squared. I'm going to take the square root of both sides, so that's going to be a plus minus square root of 2 equals x. Remember, you can't have a length that is negative, so I'm going to throw out the negative. So that yields one answer as x equals the square root of 2. And then if I set the denominator equal to 0, I will have 4 equals x squared. So x will be the square root of 4, which is going to be the plus or minus 2. I throw out the negative because I can't have a negative length. And so 2 equals x. So it appears in this that I've got 2 critical values. But if you think about this, if we plug 2 back into the original, wouldn't that tell us that y is equal to 0? Well, if y is equal to 0, that means we would go right 2 and up 0. That does not yield any area. So we can throw this one out because it won't work. So that means the only critical value that we have that could possibly work is the square root of 2. Now, I could do a chart to show that it's a maximum, but it's the only number that could possibly work. So you're okay to just assume that that is your value. They ask for the largest rectangle that could have these dimensions. So if x is the square root of 2, and I plug that back in to figure out what y is, I would have the square root of 4 minus 2 equals y. So that would be the square root of 2 for y. So my two dimensions would be, my x value is the square root of 2. So that, remember, is just half of this length. So that means I would have square root of 2 plus square root of 2. So my length
would be 2 square root of 2. My width would be the square root of 2. And then if I wanted to find the area, it would just be those two multiplied together. So my area would be 2 square root of 2 times square root of 2, giving me an area of 4 square units to finish off that problem.